Hey, welcome to one of your first video reviews you're experiencing this year with Mr. Sandoval. Now, one of the things I love to do is kind of just go by and now a couple of things to remember when you watch this video review. It doesn't do any good just watching it. You have to actually practice it. Otherwise, it's the same thing as watching yesterday's TV episode. You're not going to remember a lot of it. Now, apart from that, the other thing the way you measure yourself, you got to know three things. You have to be able to remember, understand, and apply the material. If you could do these first three basic steps, I'll guarantee you that you will do well on the test. Which means that sometimes you have to get a new sheet of paper and then work the problems. And then from there, you'll have the benefit of then having at least this level of mastery. You need at least this level of mastery in order to at least perform well. Apart from that, it's actually beneficial if you're able to explain to somebody else. Like if you're able to teach and create, that means you're actually going to high levels of learning, and that's the thing I would love for you to do. But we all know that's it's not the easiest thing to do in a short amount of time. So let's go ahead and actually start with our review. Okay, let's begin with problem 1. Now, this means that you have to go back and review your function families. And in addition, you have to study end behavior and how it works, because then there's going to be some questions about end behavior on the exam. Now, this function family is a cube, or just a cube. The cube function family. Not cube root, cube. I know that that's one of the few ones that actually was not written inside your foldable. Make sure you write it in there. The equation for the function family is f of x is equal to x cubed, and the graph, it's pretty easily done as this. So you're going to have this kind of effect. All right, lovely. So just remember, study parent function, study the end behaviors with it. All right, with this one, domain, we have a couple of different notations you can use. I was using a lot of times interval notation, so I'm going to go from -3 to +3. Now brackets mean included. And they're included because you got solid dots. Now for the range on this one will go from -2 to +4, both included. If you like the other type of notations, you're more than welcome. Like there's inequality notation. If you want to do this is the same thing as what I'm doing right there. And the same thing as inequality notation to start here. Intercepts, you got a few. Actually, you got y-intercepts and x-intercepts. Some of these you have to estimate because you have like 2.75, 0. In addition, you have -1. Actually, actually, let me make a decimal instead, like -1.25. 0. You also have a y-intercept at 0.4. And in addition, you also have like the reverse, 1.25, the positive side for these intercepts. And in addition, you also have like 2.75, 0. This is all lovely. Local maximum, there's only one. This is considered a local maximum. So that means that in this case, you have 0.4. There's two local minimums. That one and that one. So we have the points. Oh, let's see, it's going to be, no, not 2. Oh, no, it is going to be 2, -2, and in addition, -2, -2. Now, determining if it's even, odd, or neither. Remember, the even test, it's a very easy test. Take the y-axis. Take just this side. And like if you're folding it right in the dotted line, and imagine you have wet ink. If it leaves the same exact thing, then you're guaranteed even. Now, sometimes you might be wondering, well, how did I test for odd? You do the same thing, but you have to flip it again. So you move this over here. Oops, let me take away those blue markings. And then after that, you flip again over the x-axis, and if you have a match, then it's odd. Okay, I said that verbally. Maybe you have to rewind it. And if it doesn't do either one, then it's neither. So that's pretty easy. All right, let's look at this one. Same thing, intercepts on this one will be here here, here, and here. So you're writing -4. Oops, and another one. So -4, 0, -1, 0, 1, 0, and 4, 0. And then after that, the other one would be 0, 1. Now these technically are supposed to be arrows. So the domain on this will actually be from -infinity to +infinity. The range would actually start from here and go up. So the point would be then from -4 to +infinity. Local maximum, just one. This one. Let me change the color. Identified 0, 1. Local minimum, there's 2. Here and here. So one of them is going to be at 3, -4, and in the other one, it's going to be at, I'm going to estimate this, -2.25 and -1.75. All right, lovely. Let's move forward. Well, let me see. I think there's another question below this one. Ah, excellent. All right, so graphing a piecewise function. Now, pieces of the function meant that we were going to graph it, but not use the whole thing. Like in this case, typically this line would start here, and then it would have a slope of 2, so down 2 over 1, 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 down 2 over 1. All right. And we would normally have this line. What I'm going to do in this case, I'm going to stop there. And the reason being is because of this portion. You see how it says x less than 1? That means you have the benefit of taking that off. We're starting from here, so everything from that way disappears. And I'm going to go ahead and put in an open circle to signify it's not included. Remember, there's no line. Let me erase this right here. There is no line underneath the inequality symbol, which means that you have the benefit then of that. The result of that is you have an open circle. That means it's not included. So you can't say 1 is a point. All right, now the absolute value. You want it between -2 to 2. So we're going to start the absolute value. Kind of looks like a V. So we're going to start from here. Actually, let me do it in black. It goes down this way, and then we're going to go to 2. Now in here, I'm going to put an open circle. And the reason being, again, because of this no line here. No line. So that's how we solve that. And then from there, we will move on to this other part, which is x minus 2. So typically, it would start here, and it's saying positive x. So we'll go this way. Now, what I'm going to do is I'm going to do some erasing here, because this line does not start until we get to 2. So it starts at this point. This is a solid dot because it's included. And actually only goes to 5. So it means in this case, we're going to erase these. As just consistency, all right, let's make that one yellow. Let's make a solid dot here and then connect these. There you go. And here you go. All right, lovely. So we have it that, in our case, my domain then is going to go from -infinity. My highest point is just here, the 5 included. The range is going to go from -infinity to 6 only, but not included. Intercepts are going to be at -4, 0, at 0, 0, and at 2, 0. That's it. All right, fantastic. Let's move forward. All right, write a function whose graph y equals x squared. You should define it down and compress vertically by a factor of 3. Now you got to go back and study transformations, and especially the rules, because remember the general equation for a transformation follows that any equation is going to have a f c x minus h plus k. This is the one that deals with vertical, and it could also deal with reflections. So across the x, There's a C right here. This one's a horizontal. This is not going to be so important. I don't think there's going to be any questions on there. But this one right here, the H moves things left or right, but it's the opposite of what you see in here. And then this one moves it up or down. So in this case, it's asking us to deal with an A because you see how it says compress. Now, when you hear the word compress, compress deals with values or fractions. So by a factor of 3 means that the correct solution on this one will be 1/3 x, and then shifted down means -5. I'm dealing with a k value. So that would be my solution. This one says name the parent function associated. Okay, so first of all, absolute value. Let me erase this here. So first of all, we're dealing with absolutes, and then after that, it says right here, also describe each transformation you would make on the parent function to the graph. Okay, so first of all, it's going to reflect. Always start with the ABCs. So it's going to reflect, and so I'm going to start with this value, the A value. That's its value here. And it's going to reflect across x-axis. And if you want to guarantee to yourself, like prove it to yourself, everything I'm writing in here, or even when you're taking the test, just go ahead and graph it. You have the power to do that. So then you can see the result, and then for there you can feel safe. And together you could go ahead and see if you have a correct solution. So reflect across the x-axis. It's being compressed. I'm using the word compressed because it's a fraction by a factor of 2. It's being shifted to the left because it's going opposite what you see because of this h value right here. But it's being shifted to the left by 2 units. And it's being shifted down by 5 units. Okay, excellent. Now let's come over here and I'll do this one. Let's talk about the parent function. Now this one's going to be a square parent function. And let's see the directions, what this you want us to do. It says graph each of the following functions using the techniques of shifting, compressing, stretching. Start by graphing the parent function, explain the transformations made to create the new graph. All right, so let's go ahead and do this. Let's begin with the fact that our parent function is going to look like this. 2, 4. So this is the parent function, made it in yellow. Couple transformations. We're going to vertically stretch by a factor of 2. And we're going to shift to the left one. Actually, not to the left, to the right. Remember, it's important that it's always opposite what you see. So we're going to shift to the right by 1 unit. So let's go ahead and do that. Now, when I do the vertical stretch, we take each of these points and multiply by 2. Now, this one remains unaffected, but this one is affected, that one is affected, and then these are affected as well. And then I move everything over to the right by 1. So that means that this is going to move there, it's going to move there, this is going to move there, it's going to move here, it's going to move there. So my new graph is going to look like this. And that describes everything we're doing. All right, lovely. Now, another one here. Parent function, absolute value. Let's do that one. Absolute. And then transformations on this one is going to include, we're going to reflect across the x-axis. And that's because of this negative that you see here. That's the reason why we're reflecting. So x-axis. We're going to compress by a factor of 3. And we're also going to go ahead and shift to the left by 3 units. And then after that, we're going to shift upward, or shift up by 4 units. Okay, so let's go ahead and do all this stuff. So let's start with the parent function. Start with the parent function. So we're going to go here, here. We'll make the parent function in black. Okay, and then we're going to reflect across the x-axis and compress by a factor of 3. Now, when we reflect, okay, when we start with 0, this is going to shift this way. It's going to be, everything's going to be 1/3. So instead of 2, it's going to be 2/3. So I'm going to just do a few points because I still need to do some movement. So I don't want to do the whole thing yet. So let's do some movement. So shift by the left by 3 units. So we're going to move all these few points that I came up with, these 5 points by 3 units. So let me change the color there because otherwise it's more beneficial if I do that for you. Okay, so there. And since I have kind of the idea of what it's going to do, let me just draw it in though so you can see it. Now I'm going to move everything up by 4 units. So one last color change here. So it's going to kind of look like this. So my new absolutely got affected this way. Lovely. Okay, let's move forward. Let's go ahead and talk about inverses. There's not going to be anything as difficult as 10, but I'll do it for you anyway on the exam. But the first rule you're going to have to do is steps, change f of x to y. And then after that, step 2 is change x's and y's. After you discover this, then the next step is to solve for y. So in order to solve for y, I'm going to do plus 8, plus 8. It's going to require more than one step, so I'm going to carry this forward for a little bit until I continue solving. Isolation is going to revolve a cube root. Cube root, that's going to cancel out those cubes. And my final result, well, not my final, but my solved result, it's going to be x plus 8. The very last step, you want to change the y to the inverse. So step 4, inverse of x is equals to cube of x plus 8. Okay. I'm just going to skip 10 just because I'm going to run short on time. If I have time, I'll come back to it. If not, ask me during class. I'll show you how to solve it. It's not that entirely difficult, but involves some steps in solving rationals. But that's the inverse. Now for 11, I did it. Well, let me go ahead and just do the start involves more simplification on some of these. But I want to kind of get forward to some more stuff that's probably more important in the exam. You just got to remember that this really means this, f of g of x. Which means that in this case, if I take it really slow, it will look like this, 3 of g of x plus 4. Now, I know this is what g of x is, so I have the power then to substitute. And this will be 3, 5, x minus 2 plus 4. Now this is a setup. Afterwards, you do need to do a lot of simplification. Well, not a lot, but it's calling common denominators and putting your rationals together. So I'd rather not do that section of it just because I don't think we're not going to go anything in that technical in advance. But what you would do, so I may come back to this one. Let me move forward to the g of f of x. Well, hold on. Let me take that back because I do want to get you the domain on that. All right, so in solving this, let's do 15 x minus 2 plus 4. We have to get a common denominator. This currently has a denominator of 1. Since I want to put these fractions together, I have the power to get a common denominator. Remember, this whole thing, the x minus 2 divided by x minus 2, this is really 1. But the benefit that I get is I'm able to put it all under one common denominator. So there and there. 15 plus 4x minus 8. And then when you're solving this, it's going to be 4x plus 7, x minus 2. It's going to be your solution for this one. And what I would guarantee you is that you're going to have the domain that x is an element of all real numbers such that x cannot equal 2. Now, I know some of you don't know where I got that from. All I did is I took the denominator, set it equal to 0. If I do that, I'll find out the solution for that one. If you don't have the technique to do that, just bring out your calculator, put it all in there. If you put it in there, you'll have the benefit of seeing it all. So 4x plus 7, and then from there it's divided by x minus 2. Then graphically, especially if I shift down, you'll see the asymptotes actually at 2. So let's go back and solve the other ones. Yeah, let me skip this one. Let me go into this one. This is probably a little bit more like what you'll see in the exam. All right, so let's do the composition and solve this one. This one's going to involve me putting g inside of f of x. So it's going to look like this. X squared plus 3 minus 1. So if you're going to solve this, this will then just be x squared plus 2, just like that. So the composition of this one would just be x squared plus 2. Now, since I know I know radicals, I can guarantee that x is going to be an element of all real numbers such that x is everything greater than or equal to negative 2. Now, I know some of you are wondering, why can't it just be negative 2? Why greater than or equal to? It's because in the graph, let me guarantee you and prove to you some of the solutions that will come up together. Let me show you what the radical looks like. In this case, we had x squared minus 2. Hold on, it's doing something unusual here. Let's see why it's doing that. X squared minus 2, squaring the oh, I think I know why. Okay, this problem will be slightly different. Actually, the graph you did see is correct. What ends up happening is that when you square a variable, it changes some of the properties that are in it. And what I mean specifically is that let me first erase some of this stuff. Okay, what the square is doing. Technically, what it's doing, the radical in this case with the square, is that it's not allowing any negative numbers to exist in here. For example, if there's a negative number that goes in there, it's pulling it out. So this is kind of what it's looking like. Let's go back to the graph to kind of share with you what the right solution is going to be. X squared minus 2. Okay. Every time you're putting any value that's in there, the only time the values that are ever going to be negative are the ones that are actually less than, well, let me go back home. You'll see. It's the values are actually less than when you solve for it, which is going to be the square root of 2. Any values that are less than the square root of 2, those are the values that are technically now being the ones that don't exist. So for this one, the domain, or so you graph it, it's going to be negative infinity to the square root of 2, or positive square root of 2 to infinity. And from the graph, it's the easiest proof to show you from. But technically, what we do is that we try to find out when it equals 0. And then this is the thing that we discover. We have x squared is equal to negative 2. And this is, let me take the cube root, and you can't really square a negative symbol, but at least it gives you an idea where the boundary points are. And that's how you actually solve, because if you put in values, that's kind of how it all comes out. All right, now let's go with the other one. Let's see what that one's doing. This one is actually going to produce something different. Let's see, if we do the g of f of x, you will then have the g of f of x. And in this case, for this one, it's going to be g of x. Oh, not g of x, the f of x, because that's the one that's being substituted in there. you will have the f of x squared plus string. So what is f of x? Well, f of x simply is this value that we have here. And I'll discover those cancellations. X minus 1 plus string. It's going to be x plus 2. So x plus 2. Domain is going to be from negative infinity to positive infinity on this one. All right, lovely. Let's move forward. Now, how to determine something's one-to-one? This one's going to be a graph that at 16 will be the vertex, and it's going to shoot off this way. Remember, this one is one-to-one. Yes, one-to-one. Remember, one-to-one needs to pass the vertical line test. This one is the one you feel safest and most familiar with, is the vertical line test, and the horizontal line test. And that's what this one does. Passes a vertical and horizontal line test. So, and what I mean is that you could draw vertical lines. There's only 1 point for each one. If you draw, vertical, so change that. And then these are horizontal, so same thing. All right, so this one is one-to-one. When do you fail it? If you get like one of these, or anything that does not pass. See this? That didn't happen because of this. So it's just an assumption. But this one is, yes, one-to-one. This one's a line. This one, yes. This is one-to-one too. All right, lovely. Let's move on to this one and see what this is. Okay, the commission earned by a real estate broker on a home sale can be modeled of this. So let's talk about the amount for commission of a house. So $450,000. That fits right in here. So we have that, then we're going to use this equation, 0.03, 450,000 plus 2,000. And let's bring out a calculator. So what it is. How about just use this? You have the 450,000 plus 2,000. So there it is, 15,500. That's the solution. That's, you can see it right over there in the little box. So that'll be, but that's just pretty much an easy numerical computation. Now the biggest thing to check on this, or the biggest reason why I need to use this equation, there's 3 equations on here, is simply for the important fact, or the important result that this fits exactly right in here. And that's where we got that. Now there it wants to know how much more would a real estate broker make with the sale of a house of 500,000 than a house of 450,000. Well, let's go ahead and see what the solution is for that. So we're going to go ahead and do 0.05 times 500,000. I'm going to subtract it because I want to know the difference of the, since I have the solution for the 450,000, I'm just going to use whatever that amount is. You know what, let me bring up my little TI Smart View. It could just look like just like your calculator, and then we'll have the benefit of just doing it there. So let's just wait a second while this thing pulls up. All right, great. Okay, so now let's go ahead and hit second. Ooh, it's writing. Let's fix that, and now begin into doing this. Okay, so we have second quit. Okay, we got 0.05 times 500,000 minus 15,500. Okay, so it's going to be a difference of 9,500. That's the difference. Okay, so now let's find the vertex, the axis symmetry, and the maximum minimum values for the given equation. Now for this, you're going to be using an equation because we understand the vertex comes from here, and also we have, this is the vertex equation. So f of negative b over 2a. You have to realize that we're moving to a level that's a little bit more advanced. And the reason why we want you to use the equation is because sometimes the vertex may be a fraction. If that's the case, you're not going to see it in the calculator. Now let's go through the benefit of discovering what this is a. So Let me share with you. A is -1. B is 2. C is -6. So we have negative b, which is 2, over 2 times -1. And I'm going to leave this blank because whatever we get for this is the same thing. If you notice, this and this are the same. Because of that, I'd rather not be filling it all the time. So from here, I could go ahead and guarantee you that it's going to be -2 over 2. So it's just going to be 1. Let me erase that and put that in here. So I'm going to guarantee you that it's going to be at 1. And then we just have to figure out what f of 1 is. So with that, we have the equation. So we have the power to do this. And then find out what's the value at. 1 squared plus 2 times 1 minus 6. That's going to be -1 plus 2 minus 6. So that's going to then be 1. It's going to be -5, the solution afterwards. So I could now guarantee you that it's going to be 1, -5. So let's bring up a calculator. Let's just verify that. Same thing for you to do when you were taking the exam. Use the calculator just for verification purposes. It'll at least help you understand if you're close to the right solution, or if you're not, if you need to go back and see what you might have done wrong. And I'm pretty sure that's correct. All right, lovely. Let's so this is the vertex. Now let's talk about the axis of symmetry. Okay. Now for the axis of symmetry, it's just the value x is equal to -b over 2a. And we discovered what that was. We discovered the solution was 1. So this is the axis of symmetry. Now there is only one max value for vertex. So the maximum is going to be guaranteed 1, -5. All right, let's move forward. Okay, so change the equation from standard form to vertex form. Now this is going to involve us completing the square. Now the first thing you got to do, I'm going to do this, I'll do both methods. I'll use these in the box method and also the other method as well. But the benefit that we have is, first of all, we're going to factor out the a. So we're going to do 2x squared minus 6x. Leave this alone and then put plus 15. You take the b value. Let me write it down. B value divided by 2 squared. So it comes out being as -6 over 2 squared. So -3 squared results in a positive 9. So I'm going to add 9 in here. Now one thing that's important is, just like in any regular equation, like let's say this is x, if I decided to add an 18 in here, I have to, in order to keep it balanced, like the same thing as it was before, it's crucial that I put a -18. And that's kind of what I'm doing here, because look, you take the a value, you multiply by 9, you subtract by 18 here. So this is what you do afterwards. The last step, take the 2. This is, you're going to take this, and whatever you get from here, you put it down here with the same sign and square it. And then you add those two, so it comes out being, this is a vertex form of the equation. This is one method to do it. If you prefer, there is another method which is called box. It's a little different, and depending on which one you feel safest with, is the method you want to do. Okay, it's kind of like working the box backwards. You got to always put the x on that side, otherwise it may not come out right. 2 x's on top. Take the b value divided by 2, and you know that -6x, if you add those together, will produce that b value. And then you figure out x times -6 will produce, figure out what value you get in here. So like in this case, -6 will produce that value. And in here, it would actually be -3. -3 times 2x would make the -6x. Now -3 times -6 is -18. But yet my c value is 15. So I need to figure out what needs to be added on here in order to produce this positive 15. So in this case, it's going to be a pretty big number to make that 15. It will be negative 18 plus x be 32. Oh, I see. Okay. All right. The actual solution here should have been 32, which means we need to go back to the original one and see what happened. And actually, I think I noticed what happened. 2 times 9, 18. Let me do something. Okay, now in examining this further, I noticed that this is not right. It actually, the solution, the error made was right here. Negative 3 times negative 6 comes out being positive 18. So of that, to produce this 15, that's when you have to subtract 3. And this is actually how you get your perfect square. It comes from this value. This is your C value, the new C value in our case, or the value that goes on the outside, not a C value. You can take that away. Don't consider it a C value. But you can start with the A that you see in the front. Take this portion, place it in here and square it to make it a quadratic. And then you take the value that goes on the outside. And that's done by the box method. But if you can see, we got the same solution. All right, good. Let's move on to 18. And now talk about how to express the quantity of a certain product as a demand equation. And to do A is make sure you use this equation Rx is equal to x times P. Currently it's expressed as not as x, but actually an equation of price and units. So in order to just make an expression of x, I'm going to take the benefit of knowing this and then having the power to substitute it in and solving for it. So when I do this and I distribute, I can tell you that the demand equation expressed as a revenue of x is now 1 negative 6x x squared plus 100x. So that will be A. Now B just means using your equation. If you want to figure out what the revenue is at 150 units, use the equation to discover that solution. What is it, 150 units plus 100 times 150? We'll discover that the solution comes out being, let's see, put this, negative 1 divided by 6 times 150 squared plus 100 times 150. $11,250 is the price. 11,250. So that'll be the amount for B. Now let's do C. Now for C, I'm going to erase this, so make sure this is written down on your paper. But for C, it wants me to know what X maximizes revenue, what is the maximum revenue, what X maximizes revenue, and what is the maximum revenue. They're actually looking for the vertex. Remember, one of the benefits that we have is an understanding that this quadratic is going to open down, which means it's going to have a vertex here. And if it has a vertex there, I could then use this equation, negative b over 2a, and then the f of negative b over 2a is to find out what that vertex is. So from here, I have to say that a, now a is just that negative 1, 6. B is this 100. So in applying that, I'm going to do negative 100 over 2 times negative 1, 6. And then whatever solutions I get that, I'll put it in that blank that I just left there. But let's find out what that solution is. I got to be careful in this portion. The way I wrote it is not the way you're going to write it in the calculator. If you do negative 100, and if you type it in like that, you're going to get a wrong solution. Let me show you. This is wrong. It's not right. What did we need to do? Parentheses around here. So if you don't do parentheses around there, it's going to give you a wrong solution, and I don't want you to fall into that trap. I want to make sure I get a lot of really good scores. It's actually 300. So in this case, I just have to figure out what 300 is, and then the f of 300. So f300, just like the one we did prior, where you're going to sit there and just use your equation. Substitute it in. So we're going to do -1 divided by 6. 300 squared plus 100 times 300. And then we'll discover that it's 15,000. So the solution in this case, the maximum revenue would be 15,000. Maximum units would be. Now, on D, wants to know what price to charge. You have the benefit of having the price equation, which is -16x plus 100, which means -16 times 300 plus 100 is going to be then -50 plus 100. So it comes out just being $50. So that's the solution for D. All right, excellent. Let's move into this next part, which is write the polynomial given the following zeros and multiplicities. Now, in this section here, the 0 will mean that you're guaranteed a factor like this. I say it has a multiplicity of 3. That means it's going to show up 3 times. This next one, 1, means that you have x minus 1, multiplicity of 2. And the last one is x plus 3. Now, I do have a degree 6, and the reason being is because of this. This is the solution. First of all, let me make that very clear. This is a solution. That's my factor. Now, the way I could guarantee you that I have 6 is that you add up all the x's. I have 3 x's here, 2 x's there, 1 x here. It's not written up there, but it's assumed that is 1. And if I had all those together, 3 plus 2 plus 1 comes out being 6. I'll use a highlighter. 6. And then from there, that's how you get that solution. Okay, list the zeros and its multiplicity. Okay. Now, this is going to produce a 0, and it has a multiplicity of 2. So I can guarantee you one there. I'm going to guarantee you the one at 4 because it's always opposite of each of the factors with the multiplicity of 3. And then after that, we're going to have -5 with the multiplicity of 1. You don't have to write it down, but you just have to write down the factor. And let's take a look at if there's any more. I know, that's it. All right, so please study. It would be beneficial to bring out a blank sheet of paper, rewrite the problems, and rework them. Then from there you can see if you really regained mastery of you remember, understand, and apply all these techniques that we learned. All right, and thank you for watching the video.